We want to define the fundamental theorem of calculus. If f is a continuous function on a closed interval a, b, and capital F is an antiderivative of it, then the integral from a to b, f of x dx, is equal to f of b minus f of a. So you take the antiderivative and substitute b in, take the antiderivative and substitute a in, and subtract them. Let's put this into practical use and solve some problems to find the integral from 1 to 4 of x cubed minus 2. First of all, can we find an integral of x cubed? We use the power rule. We add 1, divide by 4, minus 2x. And normally we put in a plus c. However, as we do this, you're going to see that there are two values of c, so we're going to leave this off. And normally what is done at the end, you write in the limits. The lower limit is 1, the upper limit is 4. We put 4 in for x, so we have 4 to the 4th power over 4 minus 2 times 4 minus, now we substitute 1 in for x, 1 to the 4th over 4 minus 2 times 1, and we have 256 divided by 4 minus 8 times 1/4 minus 2. So we have 64 minus 8 minus, so that would be negative 7/4. So we have 56 plus 7/4. That's 57 and 3/4 would be our answer for this first one, x cubed minus 2. To find the integral from 1 to 2 of 1 over x squared, let's write it in the other form, x to the negative 2 dx. Using the power rule, we add 1, so we get x to the negative 1 divided by negative 1. The limits go from 1 to 2. We substitute 2 in, so we have 1 over negative 1 times 2. Remember, the negative exponent means it put it in the denominator, minus 1 over negative 1 times 1, which gives us negative 1/2 plus 1, or final answer of 1/2. Let's try a trigonometry integral. The integral of the cosine of theta, remember that the sine, the derivative of the sine of theta, was equal to the cosine of theta. So therefore the integral of the cosine of theta is equal to the sine of theta from 0 to pi over 4. So we first take the sine of pi over 4, and from that subtract the sine of 0. The sine of pi over 4, if you recall, 45 degrees. We have 1 square root of 2, so the sine is 1 over the square root of 2, or square root of 2 over 2 minus the sine of 0 is 0, so we have the square root of 2 over 2.